Welcome to NetLand. NetLand is an open-source software tool for modeling and simulating the kinetic dynamics of gene regulatory networks, and visualizing the corresponding Waddington's epigenetic landscape. In this video, I'm going to give a brief introduction to NetLand. Hopefully, it can help make the quantitative models of Waddington's epigenetic landscape widely used by researchers of diverse backgrounds. Waddington's epigenetic landscape is a powerful metaphor for cellular dynamics driven by gene regulatory networks. In this landscape, the cells are like marbles rolling down a hill along trajectory towards valleys, representing stable cell states. NetLand contains 5 modules. The input module takes the user's network, then a computational model is constructed. You can modify the network structure, model equations, and the parameters. Then the model can be used to simulate the dynamics of the input networks and visualize it in the landscape. Now, I'm going to show you how to use NetLand to perform model operations, simulation, and landscape construction. NetLand can directly load a dynamic model in SBML format or network structure file, for example, TSV, GML, or DOT. To load an SBML or a network structure file, choose Load Network from the File menu or click the button at the main tab. After loading the network, the species, reactions, and the parameters of the model are shown in the left panel. The initial values of the variables for genes' activities and the parameters can be directly modified in the species and the parameters panels. The reactions panel lists the basic information of the encoded equations. To modify the reaction of a specific gene, users can click the button at the same row in the column labeled Equation. The parameters are colored in red, while molecular species are in blue. You can edit the equation in the upper window. You can also modify the network structure. A node in the gene regulatory network can be blocked to simulate the gene knockout experiment. Click the Block Nodes entry in the Network menu, select Gene on the left, and add it to the right side. If the blocked genes are involved in the reactions of the remaining genes, users will be asked to modify these reactions to remove the regulation of the blocked genes. In addition to blocking genes, users can also add genes and edges to build new nodes and regulatory interactions. Click the Add Nodes or Edges entry in the Network menu. Input the name of the new node added to the gene list below. Click Submit to add the genes in the gene list to the network. Once a new gene is added, users will be asked to verify a set of parameters, including the initial value, degradation rates. For new edges, 2 types of regulation are provided: activation and inhibition. The upper and bottom combo boxes represent the regulator and its target node respectively. Select the regulator, the type of regulation, and its target from the 3 combo boxes. Add a new interaction to the edge list below. Click Submit to add the edges in the edge list to the network. The dynamic models can be saved in SBML or TSV format. Next, we will introduce how to use NetLand to perform dynamical simulation using different simulators. Users can click the trajectory entry in the simulation menu to open the main window. Select a simulator, input the number of simulated trajectory in the number of series, set the simulation time, and set the initial values of species. The start value for each gene can be either a fixed number or a random value. The fixed initial values are defined in the species panel. For the random initial settings, a set of random values will be generated and assigned to genes after users specify the range, a minimal value, and a maximal value. Press the Submit button to start a simulation. Once the simulation is complete, a dialog box will pop up that asks users if they would like to save the results. Not only the simulated time courses data will be saved, the dynamic model in the format of SBML will be saved as well. Load the saved result. Click the Load Saved Results entry in the File menu, then select the Load Saved Trajectory file item and choose the file. The simulated trajectories will be shown on the right. For a batch simulation, the result of each simulation can be retrieved by selecting the index from the combo box. Users can calculate the steady states after simulations by clicking the Analyze Result button. NetLand will first check the convergence of each trajectory and then return the steady state and their proportions. To construct the landscape, click Landscape from the Simulation menu, choose to simulate multiple trajectories or load pre-computed data. A few parameters need to be settled. Upper boundary defines the upper boundary of random initial states. Number of simulations denotes the number of trajectories to be generated. Time defines the simulation time for each trajectory. GPDM iterations is the number of iterations for the training of GPDM. Select the visualization method. Two methods are provided. One is mapping to two marker genes, and the other is mapping to a 2D latent space using GPDM. Once the simulation is complete, a dialog box will pop out that asks users if they would like to save the result. The landscape, the simulated time course data, and the dynamic model will be saved. The constructed landscape contains three sections: a canvas with a plotted landscape, 4 control buttons, and the data grid. Users can project the landscape to any two genes selected from the combo boxes below. Double-click the cells in the data grid to get the quasi-potential value and the correspondence of a point in the landscape. Users can also plot the contour map or show a measure of points in the landscape using the control buttons. The attractors can be retrieved by the Show Attractors function. Although we designed the NetLand software originally for modeling stem cell phase transitions, it can also be used to study other cellular phenotypes such as cancer cell death, cellular aging. For more tutorials and case studies, please visit our website.